Hi everyone, Jeremy Simon here with 3D Universe. Today we're going to be looking at the Nobel XYZ 1.0A 3D printer. This is an SLA printer, so it's a little different than other printers that we've covered before. Most printers that folks use on the desktop are what's called FDM, that is fused deposition modeling. And that means that you feed them spools of plastic filament and it melts down that plastic and extrudes it through a nozzle and draws out objects layer by layer, building up from the build plate. With an SLA printer, you're using a photosensitive resin, which is cured using a laser light or other light source. But in this case, it's a laser. So instead of building an object up from a build plate layer by layer, in this case, the build plate is lowered into a tank of liquid resin, and then it slowly lifts out of that tank as a laser cures the resin layer by layer. And so it appears as if the object is growing out of the resin tank as the build plate lifts up. So the XYZ Nobel 1.0A is an affordable and easy to use SLA printer, and we're going to take a look at how it works today. So let's go ahead and take a look at the printer. Okay, so here we have the XYZ Nobel 1.0A printer. Sitting right next to it is the optional curing chamber accessory. You don't need the curing chamber, but it is nice to give your prints a nicer cured finish. They can be a little bit tacky to the touch when they come out of the printer, even after putting them in the alcohol bath, which I'll show you. And the curing chamber helps to sort of harden any residual resin and solidify the objects for you. So the printer itself comes fully assembled, and there's very little setup involved. We basically just have to put in the resin tank, which I'll show you here. Take the lid off. So you have to install this resin tank in the printer. You have to put the bottle of resin in, which comes with the printer, and you attach those two feeding tubes. And then you put the build plate in, so that just slides in place. There's a little knob here that you can use to loosen it. That slides in there. And then the calibration process is quite simple. You start the calibration from the front control panel of the printer. You loosen these side screws on either side of the build plate. And then when you run the calibration, it will lower that build plate down till it meets the base of the resin tank. This is prior to putting resin in the tank. And you can then tighten up those screws on the sides of the build plate, and that'll make sure that the bed is level in relation to the base of the resin tank. So it's pretty quick and easy to do, and then the hardware is all set up and ready to use. So next we'll take a look at the software side so you can see what's involved in getting a print ready for this printer. So the very first thing you want to understand when printing with an SLA printer like the XYZ Nobel 1.0A is that the way that it prints objects is different from FDM printers. That is, if you have a 3D model that is a solid object, as most 3D models are, the SLA printer is going to print that object as a solid object. Thinking of it in terms of an FDM printer, if that's what you're used to, it would be like you set the slicer settings to 100% infill. It's going to make that object entirely solid throughout the entire object. Now this might be fine if you're making a small piece like, I don't know, pieces for a chess set. Maybe you do want them to print solid. But for larger objects, it can use up a lot of resin when you're printing on an SLA printer to print the object solid. And so what you're going to want to do is hollow out that object using a piece of software, in this case called Mesh Mixer, which is a free download. So we're going to use Mesh Mixer to hollow out our 3D object, and we're also going to add drainage holes in the base of the object so that after it's done printing, it's easier to clean out any remnants of liquid resin that can be left inside the object. As you can often be left with excess resin inside that didn't harden, that's just sort of built up as it was printing, and you want to be able to drain that out after it's done printing as you clean it off in the alcohol bath, which I'll show you after this test print is finished. So the first thing you'll want to do is download a free copy of Mesh Mixer. It's from Autodesk and it's a free download. Now we're going to go ahead and open up a 3D object. I'm going to use this night object for a test print here. And so we're going to open that object here in Mesh Mixer. Then we're going to click on the Edit button on the toolbar and choose the Hollow option. And as you can already see in the preview, this is going to hollow out the entire object. with a thin outer wall. In this case, we have it set to 2 millimeters, as you can see in the uppermost setting there. And then you can choose other settings. I would suggest leaving most of these on the default. You can choose how many holes you want. I'm going to use 2, as the default says. And you can choose the hole radius. I'm going to set that to about 2 millimeters to make them large enough to drain the resin out easily. Then you just click on the Generate Holes button, and that will give you a preview of the holes, which you can then position. And you'll notice that it puts these placeholders on the bottom of the object. I'm just going to drag them so that they're closer to the outer side of the object, but still within the hollow portion. And that way it'll be easier to drain that liquid resin out after the print is finished. And then I'll click on Accept. And that will go ahead and hollow out the object. And as you can see, there's now 2 nice holes in the bottom, and you can sort of see up inside there, so you can kind of tell that it's hollow on the inside. Now we're just going to save this as an STL file using the export option under the File menu, and then we'll take that STL file and import it into the XYZ software to prepare the print job for the printer. So here we have the XYZware, which is the software that is provided for the Nobel printer. We're going to go ahead and open up that STL file that we generated using Mesh Mixer. And you can use the controls in the software to rotate it around, orient it the way you want, and you can also scale the object. So I'm going to go ahead and rotate it so that it's facing front, which isn't really important because you can't see it very well while it's printing. This printer has to have the cover on while it's printing, and it's a pretty darkly tinted viewing window, if you will, on the cover, so you can't really see a whole lot while it's printing. But we'll go ahead and orient it towards the front, and I'm going to go ahead and scale it up so that it's significantly larger. I'm going to use pretty much the maximum build size for the printer, which is a pretty good size, just about 8 inches in height and 5 by 5 inches in the X and Y dimensions. So we're going to print this just about maximum size. And you also have the ability to generate supports for your object. I'm not going to need those for this particular object, so I'm going to leave that turned off. And we'll go ahead and slice this object and get it ready for printing. Just click on the Export button and select the printer that you're using, and the type of resin that you're using, and the color, which does matter because it uses different properties for the laser for the different colors. Select the layer height that you want and the build quality. We're going to go with good as opposed to normal. So it'll take a little longer, but I prefer quality over speed. You can optionally enable a brim. I'm not going to use that here. I found that objects stick to the plate very well, and I generally have not had to use a brim. If you're printing an object that has very little contact area with the build plate, then a brim can be useful. And now it's going to go ahead and do its slicing. Now, the slicing does take a good deal longer with the XYZware software compared to other slicers such as Cura. In this case, it took about 15 minutes or so to slice this object. So you'll have to be patient. But the good news is you don't have nearly so many settings that you're working with in the software, so chances of having to reslice your object again and again are pretty slim. Okay, so now that we've got our print job prepared, we saved that to the USB flash drive, which is included with the printer. I've inserted that USB flash drive, which goes into the rear of the printer, so that's already been inserted. And now all we have to do is start the print job using the front control panel. So we'll just use the arrow keys here to go down to Print from USB, and we'll select that night print job that we just prepared, and press OK to get that started. Do we want to start? Yes. Now it's loading that print job, and it's going to check to make sure everything is in good order with the print job and that we have the proper type of resin loaded based on how the print job was configured, and then it'll get started printing. Now this printer is really quiet, so once it gets started here in a moment, I'll show you what it sounds like, but it really doesn't make a lot of noise while it's going. Another thing I want to point out about the printer is that it has automatic management of the resin in the tank. So you don't need to worry about making sure that there's enough resin in the tank. It will automatically fill the tank from the bottle that's inserted, as needed. So during the job, if it runs low on the resin in the tank, it will automatically insert more from the bottle. And if the bottle runs out of resin, the printer will pause the job and tell you that you need to install a new bottle. So the automatic filling of resin is a really nice feature that makes it real easy to use this printer. You don't have to really worry about the resin, you just have to replace the bottle when it tells you to. And other than that, the printer handles the resin in the resin tank for you. Okay, now it's getting started. You can hear the build plate being lowered down into the resin tank to start the job. And because a laser is being used for the printing, the printer will not allow you to print with the cover off. So unfortunately there's not a whole lot to see in this case because that front viewing area is pretty darkly tinted, so you can't really see what's going on inside. So now it's printing. Really doesn't make much noise, so I'm not sure you'll be able to hear much in the video, but it is a very quiet printer, and so it would run without any issue in the back of a classroom or sitting on an office desk without bothering anybody. So we're just going to let this go ahead and print. This is a large print job, and it's printing at high resolution, so this is going to be close to a 20-hour print job. Okay, so our print has finished now. Take the lid off. And can loosen the build plate here, slide that out, and you can see our finished print. Looks real nice, although it is coated in a sort of a tacky coating of resin, so a couple of steps remain. We're going to take it off the build plate and we're going to clean it off in an alcohol bath using the tank that is provided with the printer. So I've got that there on the counter filled with regular isopropyl alcohol. So we're going to clean it off in that, and then we're going to put it into the curing chamber for final curing, and then it'll be ready for display. So before I remove the print, I'm going to go ahead and put on some disposable gloves so that I don't get resin on my hands. They give you a few of these with the printer, but you'll want to pick up a box. They're very inexpensive. Just get the non-powdered variety of disposable gloves. Okay, they give you this tank, which is closable, and I've got that filled with just plain isopropyl alcohol, the 91% variety. And now we can take the print off of the build plate using the print removal tool. And it does stick on there pretty well, which is a good thing because you don't want your print coming loose during printing, but it can take a little bit of maneuvering to get it off the plate. So there we go. And now we have a finished print. Again, it's got kind of a tacky residue of resin on there. You can see on the bottom we do have these drainage holes that we put in before we did the print, and there is some extra resin in there that's kind of leaking out of those holes, and so that's all going to come out during the alcohol bath. So we're going to go ahead and put it in. Now this is a very tall object, so I'm probably going to have to sort of turn it upside down. I'll do it this way first, let it sit here for a few minutes, and then we'll have to turn the object upside down and immerse it to get the other side. So I'm just going to move it around a little bit so that we can get that alcohol worked inside those drainage holes so it's getting into the interior of the object. And I'm going to leave it there for a while. Shouldn't take too long. I'd say 3 to 5 minutes is good for a typical object. If you can sort of keep it moving around or agitate a little bit, that can speed it up. I'm just going to leave it there, and that should clean off most of the residual resin. And then after the alcohol bath cleaning, we'll put it into the curing chamber there for about 10 minutes, and that will help to harden any remaining residue that's on the object, and we'll have a nice finished object then. Okay, that should be about good. Now we're going to want to let that dry for a few minutes so that all of the alcohol evaporates, and check to make sure there's not much of a residue left on the object. So we're just going to leave that here for a moment. For cleanup, I usually just use a piece of paper towel, dip it some in the alcohol, and then we can use that to simply wipe the excess resin off of our print removal tool and clean off the build plate, which has a little bit of resin on it. And that's about all there is to it. I'm ready to put the build plate back on the printer for the next print job. Put a lid back on the alcohol tank. Now I'm just going to give the object a few minutes for the alcohol to dry, and then we'll put it into the curing chamber to finish it up. Okay, so now our object is pretty well dried off, and the only remaining step is to put it into the curing chamber. This is an optional accessory. You don't need to do this, but it does help to provide a nicer finish on the objects. It takes care of any of that residual resin that might not have fully been cleaned off in the alcohol, and it'll harden that up so that you have a nice finish to the object, and it won't be tacky like it might be otherwise. So the curing chamber is really easy to use. You just turn it on, and it defaults to 10 minutes, which is pretty good for most objects. If it's a smaller object, you might do something a little less, you could adjust it a little bit longer, but I find that the default works pretty well. So we're just going to put the object in there on the platform, which is a rotating platform. It's sort of lined with mirrors, and it'll basically use a bright UV light to help cure that object as it rotates around in there. So just close the door and push the start button, and you can hear the table rotating, and the timer will count down until it reaches 0, at which point it'll give us a little beep indicator to notify us that it's done. And so we'll check it in about 10 minutes. Okay, so the curing chamber has finished its job. And we can just open it and take our object out, and it's nice and dry to the touch. Still a couple of spots I can see where there might be just a touch of resin that's not fully cured, but that'll take care of itself as it sits on a shelf over time. So there's our finished object. And as you can see, the detail level on an SLA print like this is quite nice. It's got a really nice smooth surface finish, really nice details in the geometry. They show up really well. It would be difficult to achieve the same level of quality on an FDM printer. So that's our look at the XYZ Nobel 1.0A, new and improved model of their SLA printer. I hope you've enjoyed watching. Thanks.